Hello and welcome everybody. In this video we're going to continue solving quadratic equations. Today we're going to look at using the quadratic formula to solve a quadratic equation. Alright, well let's look at what the quadratic formula is. Given a quadratic of the form ax squared plus bx plus c equals 0, then the quadratic formula is this right here. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. The quadratic formula works for any quadratic equation. So if you ever kind of forget what to do, you can always just default down to the quadratic formula. The one thing about the quadratic formula, though, is it's not always the quickest. So if there's a quadratic equation that you could use, say, the factoring method with, you should use it. It'll be quicker with the factoring method, but you'll still get the right answer using the quadratic formula. All right, examples. X squared plus 2x minus 15. All right, so first of all, I notice it does have a linear term, so I could attempt factoring, but we're learning about the quadratic formula, so let's look at it. First thing we're going to do is try to pick out the a, b, and c values. So a, b, c. So the a value is the coefficient of your quadratic, so it's going to be 1. The b value is the coefficient of your linear, so it's going to be plus 2. The c value is your constant. So a is 1, b is 2, c is negative 15. All right, then we should likely write down our quadratic formula again. X equals negative b plus or minus square root of b squared minus 4ac, whole thing divided by 2a. Now that might seem like that's a crazy formula and you'll never remember that, but you will. You just write down a few times, you'll remember it. All right, so negative now times my b value, plus or minus. Something I like to do when I'm using formulas is I'm just going to go through and just put brackets every spot I have to plug something in. Now I won't do this without doing it personally myself, but when I'm showing people I like to do this because it just kind of drives home the fact you should use brackets. But anyway, so my first bracket there should be a b again, so that's 2, then an a, and then now my c, negative 15, and then an a again right there. Okay, so I've plugged everything in. Once you've plugged everything in, after that, you don't have to think too much. You just kind of slowly calculate. So negative times 2 is negative 2, plus or minus. 2 squared is 4. Negative 4 times 1 times negative 15 would be plus 60. All divided by 2 times 1, which is 2. So negative 2 plus or minus root 64, all divided by 2. All right, so root 64, I know that's 8. So I'm going to go negative 2 plus or minus 8 divided by 2. And again, notice we have our plus or minus here. So that means this is actually 2 expressions in one. So I'm going to write them both separately and then solve them separately. So my first answer, I'm just going to put a little subscript 1. That's just kind of a Troyism. You don't want to do that or anything, but just to keep things straight. Negative 2 minus 8 divided by 2. And then my second expression, would be negative 2 plus 8 divided by 2. I'll finish my first answer now. So negative 2 subtract 8 is negative 10 divided by 2. Negative 5, my answer there. For my second one, negative 2 plus 8 would be 6 divided by 2, 3. So my two answers would be negative 5 and 3. And remember, these are the values of the x-intercepts. All right, so that is an example of the quadratic formula. It's pretty easy, straightforward. It's just not fast. It's slow. So like it would have been easier for us to use the factoring method in this case. So that's why we have different methods. If you have the linear term, use factoring. If you don't, use square root. If it's just kind of a really tough, ugly numbers, use the quadratic formula. Okay, B. So again, I think the first thing you should do, write down A, B, and C values. So coefficient for the quadratic is the A. Coefficient for the linear is the B. Constant is the C. So 2, 4, 1. Write out my formula. Negative B plus or minus b squared minus 4ac, all divided by 2a. Again, I'm going to go through and just leave these open brackets. and I'll come around after and I'll plug things in. That's actually pretty important in this first term, because sometimes I'll see students think that if the b was negative, that really I plug in a negative, so I'd have negative times a negative, which is positive, but they think because the b already has a negative, they don't need to write their negative down. Having these brackets just kind of cleans that up. Anyway, so b is 4, then a is 1, put that one in 2, and my c is 1, a is 2, you're likely shouting at the screen there. C is 1. All right, so everything's plugged in. So now again, I just kind of take my time and calculate. So negative 4 plus or minus 16 minus 8, it looks like, divided by 4 equals negative 4 plus or minus 8 all over 4. Now, we have a radical again. So we want to simplify that. I'll go over here out of the way. So root 8, again, it's a square root, so I'm looking for the largest perfect square that's a factor of 8. If it was a cube root, you'd be looking for the largest perfect cube, but we won't be dealing with that, so just square roots. So what perfect square is a factor of 8? So 4 would be, and then 4 times 2 equals 8. Square root of 4 is 2. I can't take the square root of 2, so I'm stuck with it, so I have 2 root 2. So if I go back, excuse me, I get negative 4 plus or minus 2 root 2 all over 4. Now, if this kind of depends on the textbook, but the textbook you'll be using, the way they like to write their answers is they keep it as one fraction. Now, if you notice these three numbers here, if you find a common factor and can divide that common factor out of those three, all three, not just two, all three, then do so, and that's how we'll simplify it. So I can divide by 2, so that would be now negative 2, 1, 2, so I'll rewrite it. Negative 2 plus or minus root 2 over 2. That would be my final answer, my simplified answer. So I'm going to write it, and remember that is actually two expressions in one, so I could write it like this. We typically don't, because math people are lazy and they try to find shortcuts for everything, and the shortcut is the plus minus sign. So we wouldn't usually write it out twice like that. We take advantage of that plus or minus sign. The other thing I wanted to mention though is that, again, like I said, you can kind of simplify this another way too, or you definitely can. It's just nice to kind of always match the textbook, because then it's easier to kind of to compare your answers. So the other thing you can do is you can just break up your fractions. So I could have negative 4 over 4 plus or minus 2 root 2 over 4. So that's just a distributive property of division. So that 4 on the bottom actually applies to each individual top term. And then you could just simplify individually. So now I'd have negative 1 plus or minus root 2 over 2, because this reduces to 1/2. So this is totally acceptable too. And feel free to do it. It's equivalent to that. You really just want to match your textbook. So however the textbook is written, match it up. But like I said, the textbook that I'm going to be giving you the assignment from, it's going to write it like that. Okay, C. So we've kind of gone through everything we can go through. Like, there's no new twist with the quadratic formula. The only thing is that sometimes the quadratic itself isn't presented in the form that we need. So in this case, you can see I have a quadratic term, then a constant equals a linear. So I actually want to move the linear over. So where I move, oh, my pen, good old pen, not working right again. 1 second, you guys. There we go. Okay, so I'd subtract the 7x over to the rest of the quadratic, and then I'd put it in order. So I have my quadratic term, my linear term, my constant. From there, I can just go as normal. So I won't do any more of it. I'll just show you that. You just have to rearrange it. D, same idea. You can see I have my quadratic, my quadratic term. Then I have my linear and constant on the other side. So I can bring them all to the same side. I like keeping my quadratic term positive, so I'm going to choose to move my linear and my constant over. And again, I do that by performing the opposite operation. So 5x squared minus 6x plus 2 equals 0. And yes, why not? We might as well just finish this one. Let's go all the way through. See, I didn't, but we'll do this one. So my a value is the coefficient on the quadratic, right? So that's 5. B is the coefficient for the linear. C is my constant term. So B negative 6, C is 2. I'm going to write out over here the formula. Nothing hard, just takes a second. And again, we possibly could use factoring here. If the factoring method jumps out, like, oh, you know the factors right away, use factoring. But if it doesn't, like maybe you look at this and you're not sure, then feel free just to go quadratic formula. That's fine. Okay, I'm going to go through, leave my open brackets. Okay, so I guess I'll go, so my b value is negative 6. So notice I needed to write negative 6 in the brackets. The negative that comes in the equation by default, so right here, that's not good enough. That doesn't count as my negative. So I had to write negative 6 in there. Negative 6 again. My a is 5. Put the other 5 here. My c value is 2. Okay, so go through. Take your time, just kind of, calculate. Negative times negative is positive, so 6 plus or minus negative 6 squared is 36. Negative 4 times 5 times 2, that's negative 20 and 2, so negative 40. All over 10. 6 plus or minus negative 4, all over 10. And hopefully remember from the previous square root video, when you have a negative radicand in this case, so like the square root of negative 4, we can't take the square root of negative 4. There is no number times itself that equals negative 4, so we can't do that. Sorry, my pen died on me again there. Can't do it. And what that means is there is no answer. So that's one way you can show no answer. Like we talked about before, though, the nice way is just to have the empty set. And again, what that means, not a big deal. It's just the parabola doesn't cross the x-axis. And that happens. Parabolas can have 0 x-intercepts, 1 x-intercept, or 2. This one just happens to have 0. Here, E, it's an interesting one. I won't go through the whole thing again, but just the setup of it. The A, that's the coefficient of the quadratic term. The B, the coefficient of the linear term. But there is no constant. So what you can do is one of two things. You could write it out with the constant, right, plus, or you can just kind of know that or assume that. So my A term would be 4, my B is negative 2, my C is 0. Whenever you're missing one of those, if you're missing the linear term, B would be 0. If you're missing the constant, C is 0. You will never be missing the quadratic term, because if you're missing the quadratic, then you don't have a quadratic equation. You have maybe a linear equation. So that situation would never occur. All right, so hopefully that makes sense. The last thing we'll finish with is an example. And you can see that the quadratic equation that is in here, or function actually, that is in here is a bit more detailed. So this is a great use of the quadratic function or formula. Suppose a pebble were to fall from a 200-meter cliff to the water below. The height of the stone, h of t, in meters after t seconds can be represented by the function h of t equals negative 4.9 t squared plus 3t plus 200. How long would it take the stone to reach the water to the nearest tenth of a second? Okay, so it says how long, so that's time. So that means we're going to be actually looking for t. That means we have to come up with a value for here. All right, remember that's height, and we're wondering how long the stone would take to reach the water. So we have to ask yourself, what is the height of the stone at the water? Hopefully, if you think about it, you'll say, well, the height would have to be 0. You're right. So the height would equal 0, so, or h, I'm sorry, would equal 0. So I can actually plug that in. 0 equals negative 4.9 t squared plus 3t plus 200. So now we've taken this quadratic function. It's a function because it had h of t in it, or y. That'll make more sense next chapter. We'll get into that more. But I've turned it into an equation by placing the 0 in there. So really what I'm going to be doing is I'm going to be solving for t, which we know means on a parabola, we're going to find the x-intercepts, or the t-intercepts in this case. I don't want to use factor, even though it's got a linear term, so I'm going to use my quadratic formula, take my time, and I'll get to my answer. A, B, C. A would be negative 4.9, B is 3, C is 200. So you could write x equals, because that's what you're used to writing. If you want to write t equals in this case to make it, just to tailor it to this question, by all means, go for it. Negative b plus or minus b squared minus 4ac all over 2a. I'm just going through and making my open brackets. I like doing that when I'm teaching. If I was doing it myself, I might not do it. The b is 3. A is negative 4.9. Didn't leave myself much room, did I? Negative 4.9. C is 200. Same thing. Squishing stuff. All right, so now I just go through. Negative 3 plus or minus. This is 9. Two negatives make a plus. That would be 3,920 if you multiply all those together. Divided by negative 9.8. Keep just chipping away at everything. Negative 3 plus or minus 3,929 divided by negative 9.8. Now I got to take the square root of that. When you take the square root with your calculator, you're going to notice you get a lot of decimals. In this question, it says nearest tenth. So we can just round to the first decimal place. Hopefully my pen's working here. Oh, no, it's not. That was kind of weird. Negative 3 plus or minus. And I got 62. And when I round, I would get 7 all over negative 9.8. And again, I have two expressions here, so I'm going to split them up, solve them both. We'll see what we get. So T1, I'm just going to call it negative 3 minus 62.7 divided by negative 9.8. And then T2 over here, negative 3 plus 62.7 all over negative 9.8. Sorry that I have that kind of random mark on the page. Unfortunately, I can't erase just a little thing with this program. I erased the entire screen, so we just have to kind of push through on that. So then I'd get negative 65.7 divided by negative 9.8. All right, when I do that division, I get 6.7. Go over here, negative 3 plus 62.7, I end up getting 59.7 divided by 9.8. I get negative 6.1. So I have two answers. But if you look at it, we're talking about time. My first answer is 6.7 seconds. Sounds fair. The second one is negative 6.1 seconds. So we can't have negative time, so we don't end up counting this answer. All right? So 6.7 seconds ends up being the solution to this problem. All right. That's using the quadratic formula to solve a quadratic equation. I hope that made sense. If it didn't, talk to a teacher or come find myself. Have a great night, everybody.